Thanks to come to our lesson on Linux cybersecurity. So far we have only talked about how to protect Linux by using a feature which are actually protecting Linux from software which are running on the box, either under Linux during the boot or inside Linux, and how to create protections and isolation between the various tasks and the various subdomain by using facilities such as discretionary access control, mandatory access control, or even namespaces. Now, today we're going to talk about something completely different, which is how to protect from the external network traffic, especially IP, but not entirely only IP, mostly Ethernet, which is coming from the outside world and can get into the box or can get into the network, which then has access to following boxes. By boxes I intend workstations, servers, or IoT devices. And we call that a firewall. Firewall are in general under Linux associated with the Iptable, primarily by historical data. Today nftable are slowly replacing Iptables. We'll come back to that later, but for the current discussion there is no real difference between both. So a firewall is primarily a protection mechanism that stops you to go to hell, and hell being in that case the external world, and it protects you actually from the hell of the outside world as well. So let's find out how to go to the next page. Yes, so this is a fourth lesson of this series. We're going to look at first obviously the definition and general principles about, for example, network domains, what do we call a network interface, talk about Iptable and a bit about nftable as well, the firewall tools and how to troubleshoot that. So it should be a quite easy lesson. The concepts are pretty simple, implementation can be a little bit more tricky. First, what is a firewall? In a house, it's a wall which has a capability to resist to fire, which gives its name. Like you should have when you have, for example, a gas boiler in a public place where you want to protect and slow down the progression of the fire from one room to another. In a similar manner, we call firewall a software or a hardware mechanism. These days it's mostly software, which is protecting the one side of the network from the other side of the network. And in general, as a basic principle, we have a bad side and a good side. We'll see that it's a bit more complex in reality. How does it do that? But it creates primarily an isolation between network interfaces. So we're going to stop to do routing, bridging, like we would do in a default device. We are going to put restriction on the routing and on the forwarding. We'll come to the difference between forwarding and routing a little bit later. And we're going to use that to protect services from an external network traffic. And by external I intend obviously the open internet, but also another internal network. You may want to protect your company from the first open internet incoming traffic, but you may also want to still let that external traffic to access your web server, because otherwise your web servers, if they are trying to sell stuff to customers, is not going to work. And you may not want to let any other traffic than the web traffic to go to those servers, so you're going to make restrictions. But you don't want that incoming traffic to go inside your company. So that internal zone is going to be not completely cut out from the external traffic, but restricted, while your full internet zone is going to be very restricted from incoming traffic. maybe completely block incoming traffic. You may allow outgoing traffic, but you may also restrict it, maybe, for example, only to web, because you want to control that. So a firewall is going to be highly configurable by definition. It has to, and it has to be secure, because obviously if there is a capability to hack your firewall, you have the capability then to change every configuration or to bypass a restriction that you believe you had imposed. So it's a very important point to take a secure model to do that. Many firewall today runs directly on Linux, but you still have the hardware devices available. Traditionally, in organizing a firewall, we are going to create network domains. The most common one are the internal, which is the server, the workstation inside the company. You have the external world, which is the open internet. You have a demilitarized zone called DMZ, it's shortened DMZ most of the time, which is an area which is going to receive some traffic from the outside world and will have some access to the internal servers as well. I'll give a practical example. You have a company which is running a website which is accepting order because you have a web business, and so you are going to have a first firewall which is sorting out most of the incoming traffic, which is only going to allow some valid HTTP and HTTPS traffic coming into your own company to do some business. For example, you may do a restriction just to the website that you have the capability to do that, so going further than just a simple IP. In that demilitarized zone, you are going to run your web server, the database associated with a catalog of things you're selling, but you may let the order to go into your ordering system inside your protected area, because you don't want to get your ordering system just sitting in the DMZ. It's a bit risky. So you may have some rule. On internal zone, it's not uncommon to have multiple internal zones. Very traditionally, you're going to find a production zone, so where you have most of the normal code, a development zone for your developers. We know that all developers are naughty, they do crazy things, and they have to sometimes. You may have a test zone. I also advise to have an infrastructure management zone. It's a very, very good practice, not used enough in companies. So you're going to have multiple zones. Obviously, the more you have zones, the more it's complex to manage. Now, a lot of people say, yeah, but if I have multiple internal zones, how am I going to do? I'm not going to have multiple network, multiple wiring. We have invented VLAN a long time ago, and you can use VLAN tag to carry virtual network inside a single wire infrastructure or wireless infrastructure in company, so it's quite easy. And obviously your firewall will be capable to manage that. So as I've said, a firewall is going to work on network interfaces. So a network interfaces will be of Ethernet type. It doesn't mean that it is an Ethernet socket. Obviously it can be a wired Ethernet. It can be a Wi-Fi or a Bluetooth connection. It can be a secondary interface. On Linux subsystem, you have the capability to create multiple interfaces on a physical one, so you can have multiple addresses. Be careful, there are serious limitations on firewalling of the secondary interfaces. So I would definitely prefer VLAN with tagging. If you try to manage firewall, you will have significantly less surprises. And then you can have virtual interfaces. So typically you can create bridges inside your Linux machine or your Windows machines, which is what happens when, for example, you run virtual machines, or when you run container, you can have virtual private networks. on Linux, you can create tap and tune. On Windows, I believe you can only create tap, but I'm not very sure of that. But you can create the equivalent. They are fundamentally virtual interface which allow to connect in the middle of the traffic internally. But you can also have some serial and some USB devices which are passing IP traffic and will be actually viewed as a virtual Ethernet interface. And as I've said, VLAN is a bit of a side effect of Ethernet type, but should not be forgotten. It's also an interface. So when you have an interface and when you have traffic coming in, this traffic is going to go from the device hardware to the network device driver. We're going up. Then we have a device independent interface. This is where you can actually create your virtual interfaces. And from there, you're going to extract network protocols. So most commonly would be IP, but another one we use a lot is ICMP. You have a few Ethernet traffic, which are quite important. You have the traffic for routing networks, especially for bridgings. So you have a few traffic which are below IP. In general, it's another problem because we just don't let them propagate at all. But if you have to propagate them, you have to be a little bit careful about what you do. And then you have a protocol independent interface where you have your process security, which are actually talking to. And on Linux, you have a virtual file system, which also allows you to get information about these interfaces. And on top of that, you have your software talking to the interface. So the software doesn't talk to the interface technically. It talks to a system called interface, which is seeing a file, because under Unix, and Linux is in the family of Unix, everything is a file. So a network interface, once you have opened it, you receive a handler and software, and your handler is behaving exactly like a file. So that's what you have. Now, what we're going to do with the firewall, we're going to allow to intercept this code at different levels to do some filtering. In a nutshell, that's what we do. I'm going to stop that stupid Firefox, which is complaining because I have too much traffic, and so I'm going to continue. I'm going to stop. No, that will be better. Iptable or nftable concepts. As we say, they apply to interfaces. That's the first point to remember. And then we're going to define sets of rules which can apply to any IP source. Now, you can also apply some rule to non-IP traffic. Like ICMP is a very practical, common example. That's a ping. And you have capability to create a lot of filtering options. You can do some selection on the input stream, for example, on the IP address, on the port, destination, source, type of traffic, which protocol, is it UDP, it is TCP, which port it is talking about. Sophisticated firewall will be able to actually go into deeper level, for example, to check at HTTP what is the address which has been called and what is a name which has been requested in that address, which allow to do some almost proxy or inverse proxy. You don't always allow that. Same on the output stream, very similar way. You can also be able to tag applications, especially if you have a mandatory access tagging system, which can tag IP traffic, which is the case for SE Linux and for SMAC. I don't know if AppArmor does it. I would tend to think yes, but I'm not absolutely sure that it can do it. You will have to check. And so that will allow you to do a filtering from the application, which is actually sending the information. Now, this is something we have seen in the previous lesson being done directly with the Mac using SE Linux, where by creating domain, we could actually restrict the access to network traffic. using a specific SLNX policy, saying that only, in the example I gave in the previous lesson, only X guests could only use Firefox to access to the network. Here we can do the same roughly with the tag. So sometimes you have some overload, which can happen. You can do port redirection. Port redirection is a very handy mechanism. First, it does allow to hide the internal address of devices in your internal network. For practical reasons, most of the time you have to do it because you don't have enough public IP address in your network connections to connect every single devices which are running in a company on the public internet with their internal, with an external address. Now, this limitation is going away when we move from IPv4 to IPv6. But at the time we invented IPv6, we thought that the world was done with nice people, and it would be very great to have enough addresses to give an address to every single hair of every individual on the planet, and so everything could be connected directly. But since we realized that the world on the internet is not that friendly at all, and security is a serious concern, which is something that was not even foreseen when I did my first internet connections 40 years ago. But we have to protect, and so port redirection is going to stay. So when you do a port redirection, what's happened is that you do in one direction tend to be called NAT, so network address translation. What you do is that you take a device which is trying to connect from a private IP address, for example 10.10.61.1, which is a non-routable address in the public internet, and you're going to replace it by your public address, a unique public address. So it's a very practical thing to connect a 1,000-unit device on the internet. You just need one address. Can be handy to have a few, but technically you could do with one. And so what you're going to create is that you're going to change just the calling port. So you can create a TCP traffic that way. And so even if your outgoing call was living on port 80, going toward port 80, actually when it would get out of your firewall, the 10.61.1 will have been replaced by, for example, a public address and the type of 69.14.41.5, and the port will have been changed from 80 to 5,200, and then that traffic becomes unique and can work on the internet. Now the challenge is when you come back. When you come back, you may want to have a web server which does not have a public IP address. It's a very good idea. And you're going to redirect the traffic coming in the company, the port 80, to the web server of the company. But you may want to have a secondary server running on port 8080, which will be addressed in another way. And you may want to have an SSH connection, which that time is not going to be connected to the web server of the company, but to a maintenance gateway that will allow you during the weekend, the administrator, to check what's happening. So port redirection and network address translation are very practical features which actually are implemented using the firewalling system. The other feature which is commonly available on networking, firewalling, and in particular with Iptable and nftable, is actually the throttling. The throttling is capability to limit the volume of a traffic for a given time. You can allow burst. You can define your profile. It's very interesting to avoid to have a denial attack of service. So two types of throttling. One is done on volume, very commonly done with ping. It's very practical to be able to ping your company to know that it does work. that your network is live, but it's also a very easy way to put your company down by flooding the network. So you can easily reduce the ping and say, for example, that during the first 30 seconds you're going to allow a ping per second, which is plenty enough to know if the service is alive. And after that, you're going to only allow one every 20 seconds, so you really want to be tough. You can also do throttling by limiting the numbers of parallel connections, which is a very handy limitation. If you know that your web server is going to fall down after 20 parallel connections, why to keep accepting it and to get your server going down? Now, you can put a protection at server level, but obviously a malware which will find a way to attack your server using a weakness of your configuration or a weakness of the release you're running could still overwhelm your system. If you put it at a firewall level, it's a second level of protection and the traffic will never reach the server, so it's less likely to put it down. Now, let's be honest, nftable, I've started to replace Iptable. But in reality, Iptable name is very sticky and people always talk about Iptable. The reason you will see later is because in reality, when you do a firewall, you don't use Iptable directly. You always use a tool which generates the Iptable. And so the fact that it generates Iptable or nftable is, for be honest, not very relevant, except when you want to really troubleshoot a potential problem in the creation of the table, which is more a developer world or a very deep level of expertise, knowledge, which most of you will likely not need. So using tools will be your normal way of working. So let's look at table first, Iptable in. So that's for the definition of the incoming packet. You see that we can do a lot of things. The traditional one is that you're going to accept traffic, and in that case we're going to start by the options state new, which means that we're going to allow the creation of a traffic, and that will be on a port which is TCP 25, and the rule is going to accept it. So this is adding a rule to the system. Minus R, Iptable minus A is adding a rule. Capital A is adding it at the end. Now that's for opening the connection. Now you're going to have to allow the traffic on an existing connection as well. Now you can allow traffic on existing connection on any port, which is what this command is doing, saying, okay, if the traffic has been accepted as creation, then I'm going to let that traffic go. That's very nice for IP traffic, which has a connection system. But it potentially can also let people coming in, that's a thing. But you have to allow established traffic to keep going on, at least on restricted port. But quite commonly it's done for all port. A lot of people don't bother to do them manually, one by one. And obviously anything that you have not configured, you're going to drop it. That is a very important point to remember when you do a firewall. You let come what is known, and you have defined what is known and accepted, and everything else you reject it. As I've said a few times, the best solution for security is to work on a whitelisting concept. Blacklisting does not work. Okay, because blacklisting means that you know what is going to be bad. No, so blacklisting is quite good if you want to provide protection against common known problem, which may not be security, like for example performance or very heavy traffic over weekends. You may have in your businesses reason why you have known event happenings that you want to stop, but from a security point of view it's a bad model. You have to work with whitelisting. And so we see very quickly that you can have a pretty complex model. The first one is on the pre-routing. Is it a new connection? So it doesn't exist yet. Are you going to accept it? And you are going to have to decide if you want to do a mangling. Mangling is probably changing the content of a packet on the fly, which you can decide that a packet which is coming for a given address, you're going to reroute it to another address. So you're going to change that. You may decide to change a protocol. You may decide to change a port. You can do a lot of things, and very quickly you can, be completely lost with what you have done. And obviously we'll have the equivalent for outgoing packet. And as long as the system has not got out of its filtering and mangling and redirecting, it's not provided for local processing. The table out is in one way very, very equivalent. Now, as I've said, it is traditionally common practice, because it's actually commonly what businesses need, to be very restrictive in the incoming traffic and to be fairly flexible on the outgoing traffic, because the people working inside the company have to actually work with the outside world. So at a time when you had no access from the internet from your company desktop or laptop is mostly gone. There's still some businesses where it is restricted, but mostly it's gone. So normally they will be significantly more relaxed, but it doesn't mean you're going to allow everything. It's actually a bad idea, but you're likely going to allow at least email to go out. You're going to allow internet traffic, which means that you're going to have to get DNS. Now, DNS can be done inside the company with a given server, which is a quite good idea, because the DNS protocol can be used to do other things that you may not want to like. But you're going to have same principles that for the incoming traffic. You're going to work on the IP address, on the port. Is it a new connection? Is it an established connection? Obviously, you will have to allow existing connection, even if they have created from the input. That's a very important point to remember. If you create a new connection as an input, you will still have connection going, traffic going out on that connection. So you have to allow, if you allow, for example, an outgoing, an incoming traffic for SSH, you will have to allow the traffic on that established connection to go back. Otherwise, you will work in one single direction, and that's not very good. Remember that some protocol like UDP or like CMP do not have the concept of connection. Most of Firewall, especially Iptable and nftable, create a pseudo concept of UDP connection by using a timing and by using some knowledge of the protocol, but it is significantly less reliable than a TCP connection, which is really a connection established by the network. And obviously you will still have the NAT and the forwarding features that you will have to implement. So the NAT are mostly for the incoming traffic, but it can be also for the outgoing, depending what you do. Sorry, I just said the opposite. The NAT is mostly for the outgoing traffic, where you're going to hide the internal address of the device sending traffic out and replace it by a public address, which is out a bank that you will have decided is visible. It has to be a publicly viable address, otherwise the traffic will never come back. So you will have no return to your question. And the forwarding is actually quite often used in incoming tables to reroute traffic from an external world arriving on a given port to reroute it to a dedicated machine on a dedicated port which can handle it. But you can also use forward internally to do something. For example, if you want to force all the internet traffic to go through a proxy transparently, you can use that forward to do it. So it's a common method. You can also use forward until the user has not been, for example, authentified. So a very common model that you all have practiced when you try to access the internet in a public place. You start, and the first thing you have, you redirect it to a portal. That's the way it works. So the portal, formally, when your forward comes in, your request comes in, it's actually forwarded to a portal, which will ask you to have your credential. Sometimes just giving your name and an email, sometimes to give a real password, sometimes it will be to get a real certificate from a more sophisticated certificate server, and once you have that, the forward is going to be deactivated. So the forward fundamentally acts as a router, but instead of working only at level 3, it has the capability to work at a high level. And the mangling, as I've said, allows to change the packet content. Now, you can do a lot of interesting, but also a lot of bad things with that. So it can become very quickly difficult, but once again, especially with web servers, that is a quite useful feature. So now we know roughly, or we understand roughly, that we can filter our traffic, we can reroute our traffic, we can pass it to different interfaces, and we have created domain. So for example, we are capable to have incoming traffic going to the DMZ if it is going to the web server, going to the internal management gateway if it is SSH, and being blocked completely otherwise. On the opposite side, the throttling is just talking either on the volume or the numbers of connection. And you can, by the method, restrict the service to a fair usage. It is a simple but extremely efficient protection against denial of service, and it's something that you want to associate to the C groups that we have seen in the lesson 2, which did allow to more or less guarantee that you will have still a little bit of CPU, a little bit of RAM, a little bit of network bandwidth. But here we're talking about the external bandwidth, by opposition to the C group, which does only see the bandwidth of a given device. And so you can guarantee that you will have always a minimum bandwidth for emergency SSH connection for understanding what's going on, or even to cut the traffic on the server, which is getting crazy. So it's a very, very important point. So here I just give an example, a very basic one, which is using Iptable to create a limit on ICMP, and the common thing is to limit it to 1 by second. Why? Because a standard ping is actually making a 1 per second call. And you only allow ICMP type 8, which is the one of the ping, because you don't want to let people do discovery of your network or anything like that. So it's a practical example, and we see in this graphic the difference of a ping getting crazy before you activate the throttling, and as soon as you activate the throttling at 12 o'clock, you see that the ping traffic is actually put under serious control. So it's a one common example that everyone should have implemented on any external facing service. Now, the configuration of a firewall is far too complex to be done by hand. Iptables are extremely complex. You have to define the rule by one. They add one after the other. They can create some fork in the time, and you still have to remember and to understand what everything is happening. The nftable are actually easier to use on the command line, significantly easier. They're also a little bit quicker, but it's still not obvious at all. And the risk of error is huge, which means that it becomes unmaintainable, which is stupid because there are many good free tools available to do that work for you. And the reason why most of people who do security in practical don't know the Iptable and the nftable command is because they don't use them. They actually use tools. Now, with CentOS, you have Firewall D, which is provided, which is a very sophisticated tool. I listed a few other. Easy Firewall is one which has a web-based interface, which can be practical. It doesn't do much things. It's not as sophisticated as Firewall D. I use personally a Firewall in my own system. It is also capable to do very complex system. The interesting point with Firewall is that it actually generates the tables. So it still creates very basic standard tables. So if you want to troubleshoot them, you can look at them quite easily. But they all are valid. You know, quite often the best is to provide the one given by default with your distribution, as long as it does what you want. And then stick to that one, because then the maintenance will be done for you by the distribution. It's a very important point. So if you look at how the system works, here I have the graphic of Firewall D, and so it's a daemon, its name indicate. You talk to it by a dbus interface. On the modern software today, we would use a web REST interface, but it does the same job. And that will allow you to have a command system. You can have a CLI, you can have a UI, you can have some applet on the web, and that's the interesting point. You also have a command offline mode, which is a very important point if your system has been hacked, because you may want to be forced to change some of your rules in level 1. You remember when we did the first lesson around the boot, we talk about changing the kernel command line at startup, and then you can boot your system in single user mode by putting a 1 at the end of the kernel command line in the grub, by editing the grub command line before booting Linux. The challenge is, once you do that, you have no system network at all on your system. You are very, very basic, and particularly you don't have dbus running. But that's quite interesting, because if you have been hacked and your system crashes as soon as it starts, because you have, for example, too much traffic from the outside world, Firewall D will allow you to make a configuration offline by using a more basic command. And those are going to generate Iptable that will allow you to block your traffic. It also has a backend to network manager, which is a network configuration tool used by typically laptops and by desktop, where the network configuration is done after connecting the user. So you remember when we talk about the boot, we have seen that when the login manager is triggered, it's executing task. On the laptop and at the desktop with a modern distro, the network configuration is done only when the user is actually logged. At least for Wi-Fi, that's done always like that. So that can be quite interesting. And now we have understood how to isolate our traffic between different domains in order to do protection. We have learned that it was stupid to try to do it directly with the Iptable and nftable, and we are smart and we've been listening carefully, and so we have decided to use a tool to create a configuration. Now, it's still valuable to troubleshoot that it does what you want. Now, obviously, if you do basic things, most likely it does. But if you are in charge of a cybersecurity in a company, and if the company has decided to pay a cybersecurity expert, it's likely because they want to do a little bit more complex things. So you have to do tests. You don't want to see what's happening here, where we have some bad traffic which has found a hole in the firewall by using a side door, or by actually digging under the wall and using a complete different route. For example, instead of going through the external interface, it goes through a virtual interface, and that has been found, and it gets through there that way. Or through an established connections that is hacked dynamically when the established connection has been accepted by the firewall. Now, you can do very basic things. For example, a lot of people forget that Telnet can very easily change a port. So if you want to check that the TCP traffic goes through a port, you type Telnet, IP address, space, and the name of the port. It's that simple. It works instantly. Very practical tool to check, for example, if an SNMP things is running or anything else. So that's things you can do. Same with a command like curl. You can change a port very easily to check if you have web server responding on hidden port. But doing all the port by hand is very complex. So there is a tool on Linux called Nmap, which is going to create a network scanner. Remember that doing scanning of the network on the open internet is very quickly illegal. It's actually illegal to do any scanning, but if you do it on your own machine, obviously it is your decision, so you're allowed to do it. But you just have to remember that. If you want to test that one of your provider or subcontractor is well protected and you run an nmap without asking him, you may have trouble. So don't forget that detail. And ZenMap is actually a UI version running on top of nmap, which does nice report, make it easier to use. I'm not a great fan of UI in general, but when you're using tool very rarely, it's easier than to understand and remember all the command line, which we all don't do. The other things you have as a tool is the traffic monitoring. So it's very simply, you can try to create traffic which is going to violate what you have done, or check that what you have configured to be protected is actually protected. And if you don't understand how the traffic is coming in, you can monitor, you can check what is coming in your box in and what is going out. The tool for that is TCP dump. That's the command line version of it. And the graphic version running on top of the same system is Wireshark. There is also a command line version of Wireshark, which allows to run the server. And those will actually put an interface in promiscuous mode, which means that you can monitor it. Now, remember one very important detail. When you put a network interface in promiscuous mode, you plug your monitoring system before the firewall rule. So that's very important. So you're going to see the traffic coming in, going out. So on the going out, what should have been filtered is going to be filtered. But what is coming in, you're going to see all the traffic before that the firewall is applied. So it's important to realize that if you want to know your traffic, you have to put it at a place which is an intermediate interface receiving it. For example, you can check what is going outside in your public network. And I also use Iptable a lot. It's a very basic tool, but it's very useful because you see the traffic by port, by address. It's quite handy to make a very quick check that things are happening as you expect, or roughly as you expect. Now, if you have to do a firewall, you can do it inside a server or inside a desktop, which is potentially a good idea. For example, if you have laptops which are taken by your employee at home, you should activate the firewall on this laptop because they are a good candidate to be hacked. People use them in public places like train stations or like hotels, and you never know what's going to come in. So keeping a firewall on those is a very useful thing. If now you're protecting a network from a company, running the firewall on a shared device is a bad idea. It's a very critical function, and you should isolate it on a dedicated device. And the best is to run, in that case, a dedicated firewall distro. Now, you could obviously take, if you're running, for example, Red Hat in your company, you just take another piece of hardware, you put Red Hat on it, and you use Red Hat. Yeah, it's one way to do it, and you put Firewall IDE. But let's be honest, people doing Red Hat are not spending 100% of the time to create stuff which is designed to make network traffic and network isolation. I've listed 2 distributions of Linux. There are a few others, but that's 2 commonly used. One is OpenWRT. The interest of OpenWRT is that it runs on PC, but it also runs on dedicated hardware, which are cheaper and easier to maintain than PCs. They are network devices. It has an integrated software update. And what I like is that all the configuration are managed as metadata, which are independent from the distro. So when you do an upgrade, your metadata, which are defining your network interfaces, network restrictions, are kept isolated. So it's a very easy way to upgrade. It's a project which has been running for a long time. It can do a lot of things, more than Firewall. It's also a very good way to implement access point for wireless. It's used by a lot of telcos in the world to actually provide the routers that they give to their millions of users sitting in their home. Definitely something to look at. Hyperfire is a dedicated firewall Linux distro. They use GR security as a security system, which is, it's a pretty good system, but it's not that clean on the license issue. But in that specific case, it's okay. They use it in a reasonable way, and it's quite easy to configure. The main advantage of this distro is that they are designed to be configured in an easy way. So that's something you definitely want to look at. Obviously, you can still buy specialized hardware. Cisco may be one of those. It's not always safer. I have to be very clear on that. Actually, numbers of them are actually using Linux and quite often OpenWRT under the hood. But it can be easier because your guy has been trained for Cisco and he knows how to use it, for example. That's not a bad reason to use it. At the end of the day, the way you do it is only important in the matter that it has to be done. You must have a firewall. You must have a well-defined firewall, know really what you want to allow. You have to check that you have allowed, only open what you have allowed. That's a very important point. And then you will know that chance to get into your protected world is reasonably well protected. Obviously, more than anything else, any distro running firewall function needs to be kept up to date with all security patches. It's a critical point. Okay, it's important on the other one, but for the firewall, it's a critical point. So we arrive at the end of the lesson. As I've said, it's a pretty simple one. So Iptable and nftable, they are for use equivalent. They actually have the capability to implement the base for packet manipulation and packet filtering. They are powerful, very low level, and so dangerous to be configured by hand. It's quite nice as an exercise to understand, but on production it's definitely not a good way. Using a firewall configuration tool is significantly safer and should be preferred. It will describe the firewall as metadata, so you will still have to understand how it works, but then it will create the correct tables. And if there are weaknesses, workarounds that are known, they will actually, during the update, implement the correction without you having to change anything, because if your metadata describe what you want it to do, the weakness this one's corrected will be automatically implemented. And what isolation are you going to do? Obviously, you are going to protect the internet entry point, that where a lot of bad things happen, so you don't want to have that. But you also want to protect any valuable connected device, in a very independent way. That's something that too little people do. You can create a dedicated network, but for example, if you have an ordering system which is working on a web REST interface and should only receive information coming from the web engine, which is creating the order, and from the sub network from the commercial department, it's not a bad idea to actually implement a firewall on that device and to restrict traffic coming from there, and only allow, for example, SSH connection from the IT guy coming from the dedicated VPN network and from the maintenance, which means that you are going to restrict things. So if the network is attacked internally because someone had an email and opened the files that they should have never opened, and that has created an entry door, and a malware starts to run and scan all the machines trying to find out the database with all the customer name an order, it actually will not find that ordering machine easily, and it will not have access to it in a normal way, but just by the limited ports that you have enabled. You should also implement Firewall on any laptop which is going to travel. That's a very important one. Two things. Don't forget virtual machines and containers. You know, they are machines like the other one, and they are connected over a bridge, which means that any protection has to be re-implemented. And once again, I will never tell it often enough, whitelisting strategy shall prevail. Okay, blacklisting doesn't work. You have to create whitelist and implement what you want, and only what you want. As every time, after a lesson, we'll look at what's going to be the homework to really having you to understand practically the concept that we talked about. So because we use CentOS, you're going to implement Firewall D, which is a standard package on CentOS 7. You're going to install it and activate. First thing, you're going to create a limitation of ping at 1 every 10 seconds. Default is 1 per second, but as a normal ping command does 1 ping every second, if you put that limitation, you will not see it immediately. If you make it every 10 seconds, it's going to be very obvious that you slowed it down. Then I will ask you to stop any incoming traffic except the HTTP, DNS, and SSH. Obviously, that means that you have to get services waiting for the other traffic, but in the prerequisite for this course, and what I would call the lesson 0, I ask you to actually implement Apache on your CentOS, so you should have a web server waiting for being able to serve pages on port 80, so then you should not see it. Then I would like you to restrict outgoing traffic to only HTTPS and check what's going on. And reroute any HTTP traffic toward an address where a mini server will return an error. And that mini server could be your internal Apache server. So if you do that workshop well, when you will try to go on the internet with HTTPS, it will work. So if, for example, you have a webmail account on Gmail or Yahoo, you will have capability using HTTPS to get to that one. But if you try to access a regular HTTP website, you should be redirected to your internal Apache web server, which will serve you the test web page as a result. Once you've done that, get a quick look by hand at what has been generated. I've said I don't advise you to even lose time to learn to create Iptable or nftable by hand. If you want to do, you can, but for me it's a loss of time. But you should understand what they've done. You know, there is a big difference between being able to write them by hand or even to troubleshoot them by hand and just roughly understand what it is. That you should have. And the other point you need to do is, because you're going to have rejected traffic, especially when you will have rerouted traffic, look at the log of what's going on, and you will see that in your configuration of Firewall you can define how much log you want. Because obviously if you don't do your log well, you're going to overwhelm your traffic, your server by just having log. So one way to put the server down is to create a lot of invalid traffic, which is stopped by the Firewall. The Firewall creates a log, and the log is actually putting the server down because it blocks access to the I/O system. So have a look at that. Before finishing, I wanted to show you a few websites that I have selected. So the first one, if you want to look at what are the difference between Iptable and nftable, just make a simple Google search. You will find many websites talking about it. So the syntax is definitely very different. Syntax of nftable is definitely simpler. It is more flexible, yes, and it has some improved performance. Interestingly, you have additional counters, which can be quite nice for statistics. But otherwise, it's not much difference. Then you have the documentation from Firewall D, and that's important to look at it because this is what you're going to use with CentOS. So it's available on Fedora and CentOS. as usual, and you can see the different area that they create. You know, they do public, external, they make a difference between both, DMZ, work, home, internal, trusted. So they have actually a numbers of domain, which by default a little bit more details than what I gave. You could create some more, but that are the default one available. I also talk about Firewall as an example. You can look at it. As I've said, the interest of Firewall is that it creates tables which can be implemented manually. So if you have, for example, a simpler device like an embedded device which does not have the power to run Firewall D, you can actually create tables using Firewall manually and put those tables at boot time on the device you want. So it's one way of doing it. And I talked about dedicated distro. So one is IPFire. You can find it on ipfire.org. So it's a firewall zone with different model. I also talk about OpenWRT. So it will take a bit of time to come. I thought I had it open. So OpenWRT, the main interest, as I've said, is that it runs on a lot of different hardware. So that's things, but you can see that you have a lot of different hardware which are supported. You know, support for new devices, the latest one, a Linksys WRT 1900, a D-Link, Linkit, Grainstorm, TP-Link. So you have a lot of dedicated routing, networking hardware which are easier to maintain. They don't have a fan, they don't have a screen, they're just, you know, designed for this type of job. So it's not a bad way to do it. So that's a big interest in WRT. With this, I'm going to wish you a good time doing your homework, and we'll talk for the next lesson. Meantime, I wish you to have a lot of fun with firewalling and protecting your network. Bye-bye.